Nomenclature of coordination compounds. Our next topic is nomenclature of coordination compounds. In nomenclature, according to IUPAC, which is International Union of Pure and Applied Chemistry, the naming of the coordination compounds according to IUPAC is this coordination compound contains two parts. This first part in the coordination sphere is cationic part, and these outside the coordination sphere are called counter ions, or this is anionic part. It means coordination compounds contain two parts. One is cationic part and other one is anionic part. This is one way to represent the coordination compounds with the general formula MXNY, where M is the central metal atom, X is the ligand, N is the number of ligands which are directly attached to the central metal atom, and Y is the counter ions which are outside the coordination sphere. And the coordination sphere, if it comes first, then it comes in cationic part, and the counter ion comes in the anionic part. And this is the another way in which the coordination compounds are written. First one is the metal ion, and the second is the coordination sphere. This is the cationic part. This M positive is the cationic part, and this coordination sphere is in anionic part. These two metals may be different or same. X is the ligands which are directly attached to the central metal ion, and N is the number of ligands attached to the central metal ion. These are some common ligands which are used in the coordination compounds. Here there are common names and IUPAC names, and this is the formula of the ion. These are some negative, positive and neutral ligands. If the ion is present as a counter ion, then their usual names are used. For example, if it is present as a counter ion Cl negative, then chloride is used, which is the usual name of the chloride. If this Cl negative is present as a ligand, means X, directly attached to the central metal atom, then we write its IUPAC name, which is chlorido. These are some common ligands with IUPAC naming, and the formula here H negative we write hydrido, common as well as IUPAC name hydrido. We drop this E from in the negative ligands and replace it with the O. F negative becomes fluoro or fluorido. Cl negative becomes chloro or chlorido. Br negative bromo, bromido. I negative ido, idido, and N3 negative nitrido or nitrido. These are both same. O2 negative oxo in common name and oxido in the IUPAC name. Cn negative cyano or cyanido. SCN negative thiocyanino or thiocyaneto. OH negative, hydroxo. H2O, these are some negative ligands, and H2O is the neutral ligand, and its special IUPAC name is aqua, and common name is also aqua. CO, carbonyl, CS, thiocarbonyl. Nitrosyl, NO positive is positive ligand. Here it's common, as well as IUPAC name is nitrosyl. NO2 negative, it is nitro, common name, and nitrito N, because it is bonded with the nitrogen atom. Central metal atom is bonded with the nitrogen atom. If it bonded with the oxygen atom, then we write nitrito O. Next is PH3, that is phosphine or phosphine in the IUPAC name. In case of NH3, it is amine, AMMINE, amine. This is MENH2, which is methylamine, NH2 negative, amido, azenido, NH2 negative, imido, azene diido. This is a flow chart of writing the IUPAC nomenclature of coordination compounds, in which name of the cation is written before the anion. Then we write the name of the ligands in the alphabetical order, which are directly attached to the central metal ion. Then we mention the ligands have a numerical prefix. Suppose its number is 6, then we write hexa. If its number is 5, then we write penta. Now after the ligands, central metal ion is named. Then neutral ligands are given the same name as the uncoordinated molecules. And then the ligands are named alphabetically according to ignoring the prefixes bis, tris, etc. in case of bidentate, tridentate, tetradentate ligands. And then we write the anionic ligands. Anionic ligands, their names end in the letter O. And when the coordination entity is an anion, then the name of the metal is altered to end in ate. Let us illustrate with examples. First one is PTNS32Cl2. Here we have two types of ligands, NH3 and Cl2. And PT is the central metal atom. This is PT, which is central metal ion, and NH3 is one type of ligand and its number is 2, and Cl2 is another type of ligand, its number is also 2. There is, and its name according to the IUPAC is di. Why di? Because it has 2 NH3 coordinated with the platinum. Then we write di. According to the alphabetical order, amine comes first, then chloro, C. Then its name is diamine di. Here chlorine also 2, then dichloro or chlorido. Then we write central metal ion, which is platinum. There is no anionic part in this, then its name doesn't change. And then we write the oxidation state of the central metal ion, which is equal to 2, and in Roman letters. Here we have 2 negative ligands, 2 Cl negative ligands, and an NH3 neutral ligand. To counterbalance this 2 negative charge, the platinum has +2 oxidation state. Next example, in which CO is the central metal atom, that is cobalt. And here we have two parts. One is anionic part. This coordination sphere is the anionic part in the square brackets, and this Cl2 ions outside the coordination sphere is the counter ions or anionic part, and its name according to IPSC is, here we have two types of ligands, amine and chloro, and alphabetically amine comes first, then we write pentaamine, this is pentaamine, cobalt, here we write the oxidation state and give some space here, because first we write the cationic name of the cationic part, then we write the name of the anionic part, which is chloride in this example. Here the oxidation state is 2Cl outside the coordination sphere and 1 inside the coordination sphere. The total oxidation state of cobalt is 3, and in Roman letters we write 3. Then its name is pentaamine. Here we also write pentaamine monochloro, because one atom of chlorine is also in there in this formula. Here it is pentaamine monochloro, cobalt 3. The name of this coordination sphere is in continuity without any space, but when we write the name of the anionic part, then we give some space. This is the pentaamine monochloro cobalt 3 chloride. And next example is here again we have two parts. One is K4, which is a cationic part, and other one is this coordination sphere, which is anionic part. And the name of the compound is potassium. First we write the cationic part, name of the cationic part, which is potassium. Here its number is 4. We did not need to mention the number here, prefix. Only in the coordination sphere, those having in the coordination sphere, we have to mention the prefix for that ligands. Here we have 6CN, it means hexacyano, and this metal atom is present in the anionic part, and that's why it ends with the 8, ferrate, and its name becomes ferrate 2, potassium hexacyanoferrate 2. And the next example is here it is K3FeCN6, potassium hexacyanoferrite. Here the oxidation state is +3. These are some more examples using the bidentate or tridentate ligands, or for example COEN. Here En is the bidentate ligand. It has 2 donor atoms, and in this COEN3, this 3 is represented by tris word, tris prefix, tris ethylene diamine cobalt 2 nitrate. And the next example is H2O2 En2Ir Cl3. It has also two parts, cationic and anionic. In cationic we have two types of ligands, One is neutral ligand and other one is bidentate ligand. H2O is the neutral ligand and En is the bidentate ligand. And according to the IUPAC nomenclature, we write the ligands first in the alphabetical order, according to which its name is diaqua. This is diaqua bis ethylene diamine or ethane 1,2 diamine without any space. Iridium. Here iridium is the central metal ion and its oxidation state here is 3. And then chloride, anionic part chloride. This is with the space. And the next one is tris ethylene diamine. It has 2 coordination spheres having 2 central metal ions. First we write the cationic part, then we write the anionic part. Tris ethylene diamine nickel 2, then tetraoxomagnate. Here the name changes from manganese to magnate because it comes in the anionic part. And the next example of ion, AgCN2 negative, which is dicyanoargentate because it is anionic. Negative sign represents it is anionic. And we write here ion word at the end of the name because the compound complex having a charge. If the complex having positive or negative charge, then we write ion at the end in the naming. Next is ZnOH4 2 negative, which is tetrahydroxozincate. It is also again anionic. Then we write ion. Next is hexaamine cobalt 3. Here it doesn't change the name of the cobalt to cobaltate because it comes in the cationic part. It comes in the cation. Next is tris ethylene diamine manganese. It is again in the cationic part to chloride.